We'll start by flashing our SD card with Raspberry Pi OS. First, we're going to choose our device, which is going to be the Raspberry Pi 4 Model B. Then I'll choose my operating system. I'm going to go under Raspberry Pi OS Other and choose the Raspberry Pi OS Lite 64-bit. Then I'll choose my storage. This is my SD card connected to my computer. I'll hit Next and edit my settings. I'll set my hosting to SCUTTLE so I can find it on my local network. I've also set my username and a password so I can use it to log in over SSH. I'll connect to my Wi-Fi. And then make sure my time zone and keyboard settings are correct. Under Services, I'll make sure I have SSH enabled, and I'm going to use password authentication. I'll hit Save, and then Yes. And yes, I will want to erase this and continue. I'll put it in my computer password in order to complete this operation. Now it's complete, I'll hit Continue, and then I can remove my SD card. Within the Viam app, I'll add a new machine and name it SCUTTLE. Hit Enter, and it'll take me to the configuration page. I'll go and view the setup instructions. I'll select the platform I want to run Viam server upon. I'm choosing the Linux Arch 64 because I'm running on a Raspberry Pi. I'm going to install with Viam Agent as the default installation method now. I will SSH into my Raspberry Pi on my local network, which I've called SCUTTLE. I'll say yes to continue connecting and enter my password that I set in the Raspberry Pi imager. Now that I'm connected, I can copy my installation instructions from the Viam app and paste them into the SCUTTLE command line. This will take a few seconds to get up and running. And we'll wait for our machine to connect. Now I can exit while this is happening from the SCUTTLE Raspberry Pi. And now we're connected. I can go to the configuration page and see my SCUTTLE and that I'm online. I should be able to see my logs and see that I am actually connected and everything is running smoothly. Under configuration, I can add my first component, which will be the board. So I can search for Pi and find my board Pi here. We also support the Raspberry Pi 5, along with the Orange Pi and many others, but I'm going to select the Pi and give it a very memorable name like Pi. Hit Enter, and now we have a new configuration card here. There's no other additional configuration needed to get this running. And now we'll go and set up our encoder components. I'll hit the plus sign, component, and search for encode, and select the AMS AS5048, which are the encoders used by the SCUTTLE platform. I will select that and give it a memorable name. We're going to be setting up our write encoder first, so I'll call it write encoder. Hit Enter to create, and now we have our configuration card. Within here, we're going to set up the configuration as I²C, and then we're going to add some new I²C attributes. We're going to set the address as 65, and the bus as 1. Now we're going to create our left encoder, and this is very much the same as our right encoder. So we're going to hover over our right encoder component, select the actions menu, and then duplicate. I'm going to select the title of this new component card and change it to left encoder. We still have the same connection type. We just need to change the address to 64. Next is our motor components. We'll select our create component, and we'll search for GPIO, and we'll select our motor GPIO component and give it a memorable name. We're starting with the right one again, so doing the right motor. Create, and from here we're going to select the board that the motors are connected to, and our board component is called Pi. So from here we can select Pi, and then we can show more to configure the encoder. So the right motor, we'll use the right encoder. We'll set the ticks per rotation to 2. And this is how many signals from the encoder will equal full rotation of the motor connected to the wheel. We'll also configure our component pin assignments. And for the first line, or A, we will set it to 16. And then for B, 15. And this is all that's required to get this motor configured. Just like with the encoders, we'll duplicate this right motor and create our left motor, and then configure to use our left encoder. Our lines will now be 12 and 11. And these are the pins that are controlling the motor from the Raspberry Pi. Next is the base component, which brings the encoders and motors together into one compound component. So we'll create a component, we'll search for wheeled, and we have a wheeled base. We'll name it something original and memorable, like base. So now we select our left and right motors. So our left motor and our right motor. And we'll set our wheel circumference to 250 millimeters. And the width, which is the space between the middle of each wheel horizontally, will be 400 millimeters. And finally, we can configure our camera components. We'll go to our component here, search for webcam, name something original and memorable like webcam, hit enter to create, and then for the video path, we'll set dev video 0, which will equate to the first USB, or it's the first video device connected to our Raspberry Pi. Now that we have that all done, we can hit Command S or the save button up here to save our changes. And then we can view the logs to make sure everything worked correctly. This may take some time to get set up. Once our Scuttle is booted up with the SD card, we can SSH in and configure the settings needed for our hardware controls. I'm going to clear out the command line and then enter sudo raspi config. This brings up our system configuration. I'll go to interface options, I2C or I2C, enable, OK, hit the right arrows to go to finish and complete. And then we'll need to reboot our device in order to have the settings take place. So I'll say sudo reboot. This will log me out as it restarts the device. Now it's time to control your scuttle. Go over to the Control tab, which will load up your control cards. We can see all of our components here on the left, including our base, which allows us to move our scuttle forward and backwards, and we can see the moving feature updating in real time. We can turn back and forth, and we can even include keyboard control, where I can use my arrow keys on my keyboard to perform the same actions. If we go to our webcam, we can see it updating in real time as I go forward and backwards. In certain browsers, you'll see if you hover over a picture-in-picture icon in order to bring the video out into its own little window. You might also see a button here for picture-in-picture. So now that we have it in picture-in-picture mode, we can go back up to our base and we can drive around and use our various controls while still viewing our camera. And I can hit close in order to close out of the picture-in-picture mode.